All right, today we are going to be talking about graph characteristics. For example, the domain, the range, the minimums, the maximums, and some other key things. Okay, so here, this is a line. Okay, just real quickly, the domain we said earlier in the year of all linear things is going to be, in set notation, x is an element of the reals. And then in interval notation, remember, it was negative infinity to positive infinity. And remember that we always use parentheses with the infinities. Okay. The range we stated in set notation was y is an element of the reals. And then in interval notation, it's still going to be that negative infinity to infinity. If you think back to functions, f of negative 1, remember, meant, right, that is here, what is y when x is negative 1? And I'm sorry if you're hearing this hum. Apparently, the people outside are tending their lawns, and I have no way of muffling this, so I want to get this up for you guys today. So if I look at negative 1, where x is negative 1, is here, and I'm going to go down right here, and my y value is negative 1. So when x is negative 1, y is negative 1. If I look at f of positive 1, okay, when x is 1, y is 3. If I go to x is negative 2, it's right here, y is negative 3. Okay? And remember that the y-axis, y-intercept is where it crosses the y-axis right here. And my y-intercept is going to be 0, positive 1. So that's a basic review of functions and these graph characteristics. Now we're going to kind of take these nonsensical graph functions and we're going to look at these. So if you remember, the domain is all of your x values. So my graph starts here, right there, and it ends right here. So my x value, my smallest x value is negative 6. My largest x value is positive 7. So if I'm writing this, my domain is going to go, and it's going to include negative 6 and negative 7 and everything in between. So we say in our domain x such that it's between negative 6, so it's x is greater than negative 6, and it is less than positive 7. And we use this notation when we looked at absolute value inequalities. We also use set builder, and remember, for interval, we use a bracket here to say it's included. So it goes from negative 6 to positive 7. So my graph is in between and includes negative 6 and 7. To find the range, it's my y value. So right here is my smallest y value. Here is my largest y value. So now my range is going to be between negative 2 and positive 5. So we're going to say y such that it's going to be between, we start with my smallest number, negative 2, which is less than or equal to y, which is less than or equal to 5. In interval notation, it's included, so negative 2 and 5. Now, zeros and roots are some new vocabulary, and they're basically the same thing. They are our x-intercepts. Okay? So I have an x-intercept here. So at negative 4. I have one here at positive 4. And I have one here at 7. Now we could write it this way, or remember we have our ordered pairs of negative 4, 0, 4, 0, and 7, 0. Roots are the same thing, so that would be the same answer. All right. So x-intercepts, we just did the x-intercepts again. Our x-intercepts are negative 4, 0, 4, 0, and 7, 0. So here, here, and here. Even though this doesn't go through the line like that, it touches it, it is a x-intercept. It's a root, it is a 0. Y-intercept, where it crosses the y-axis in this case, is 0, 5. Then we want to look at where, again, this says what is y when x is negative 4. So if I come over here to negative 4, y is 0. When x is 0, y is 5. When x is 2, y is 2. And when x is 5, y is negative 2. So that's all that's asking me. When x is this number, what's y? Okay. And lastly, we have a maximum value and a minimum value. So the maximum is the highest point of my graph. So it's right here. Okay. And my maximum is going to be y equals 5. And we can say at x equal to 0. My minimum is the lowest part on my graph, right here. And we would say my minimum is y equals negative 2 at x equals 5. But this is my minimum value, okay? So the y value is my minimum value. Okay, let's look at another graph. Now the difference here is the graph ends here, but this arrow means that this graph is going to continue just like that. Okay. So my domain is going to be my x value. My largest x value is 6, but this graph is going to continue on and on and on, and it's going to keep extending out here, and we don't know where it's going to end. So we say it goes to infinity. So my domain in this case is either going to be x such that x is less than or equal to 6. Okay, because it's going to go on forever and ever in that negative direction. In set builder notation, remember I'm going to use, just like we did with inequalities, negative infinity to 6, because 6 is included, we use that brace. Okay. My range is my y values, so I got to find my largest y value, and my largest y value is there. I did sketch that in, so we're going to say that this is going to be 3. Is going to be my largest y value. Again, because this is going to keep going, it's going to go down to negative infinity. So this time we say that, oh, it keeps doing that, y such that y is less than or equal to 3. And in set builder notation, negative infinity to 3. Again, paying attention to the parentheses and the bracket. Remember, my zeros and roots are the same thing. So we're going to go, I'm right about here. So we're going to estimate that. I'm just going to say it's about negative 4 because we don't have a calculator to tell us what it exactly is. Okay. 2 and 6. And if we were to write that as ordered pairs, I'm going to put that down here with roots. It would be negative 4, 0, 2, 0, and 6, 0. Okay. Again, x-intercepts were the same as our roots and our zeros. So my x-intercepts are going to be negative 4, 0, 2, 0, and 6, 0. Where it crosses the y-axis is right here. That's going to be at the point 0, -3. Okay, my next thing is saying, hey, what is y when x is -4? So here's -4. We're going to say that's 0. When x is 0, y is 3. When x is 2, y is 0. And lastly, when x is 5, y is 2. Now, my graph has a maximum. My highest value, again, is going to be y equal to 3. And it happens where x is equal to, so I'm going to say at x equal to 3. Now, my minimum, my graph doesn't have a minimum because it goes on and on and on. So what we call this then is a relative minimum. Okay, and that means, what do we see on the graph? Well, on the graph, we see that that is my lowest point. So it's a relative minimum of -4. Okay, and it occurs at x equals -1. So today we just kind of looked at some graph characteristics. We looked at a domain, we looked at a range, we looked at minimums, and we looked at maximums. Kind of a little crash course of important things when we're coming to looking at graphs, and an introduction to that as well. Okay. So if you have any questions, make sure you jot them down so that I can go over them with you in class. Have a great night.